What are the factors on which bond angle depends? Bond angle depends on either hybridization or on the electronegativity of atoms. So, on electronegativity of atoms, which atoms? Central atom or surrounding, or both? Yes, both. So, let us see. If I take example for you, if I take example that will be more clear to you than just telling you in theory. For example, if I take NH3 and I take PH3, I take NH3 and PH3, what happens is electronegativity of N is more than P. So, what happens out of N and P, N attracts electrons of the bond more towards itself. So, let us say NH bond 2 electrons are there. So, these electrons will be much closer to N than in PH3 towards P. So, these are very close to N because electronegativity of N is more than P. So, N attracts electrons of the bond towards itself, whereas in PH3 the electrons are far away, So, what do you think, where repulsion will be more? I think you will agree with me that repulsion between these bond pair electrons will be more in NH3. So, bond angle in NH3 will be greater than PH3. So, from here you can conclude that higher the electronegativity of central atom, more will be bond angle. So, if we compare among NH3, PH3, ASH3, SBH3, what should be the order of bond angle? Down the group, electronegativity of central atom decreases, so bond angle also decreases. That is it, done. Now, we will take another example where your central atom remains same, only the surrounding atom changes. So, let us see. If I take an example of NH3 with NF3, so electronegativity of surrounding atom is increasing, electronegativity of surrounding atom is increasing. Let us see this. In N and H, more electronegative is N, so electrons will be towards N. So, electrons are towards N here, towards N here, the electrons of the bond. In this, fluorine is more electronegative, so electrons are towards fluorine, So, what do you think? Where will the repulsion be more? I think you will agree with me, repulsion will be there in NH3 greater than in NF3 because these bond pair electrons are far away. So, repulsion is more in NH3 than NF3. So, from here we can conclude higher the electronegativity of the surrounding atom, less will be the bond angle. So, we concluded 2 points. When central atom is changing, more electronegative central atom, more bond angle. When surrounding atom is changing, more electronegativity of surrounding atom, less will be bond angle. So, we concluded these 2 points from the examples we took up here. And last point is about bond order. What is bond order? As you all know, bond order means number of bonds between 2 atoms. So, number of bonds between hydrogen atoms in H2 molecule is 1. So, bond order in H2 is 1. For example, bond order in few molecules I will show you. So, bond order in H2 molecule depends on number of bonds between H and H. So, it is 1. So, bond order 1. 1 bond between Cl, 1 bond order. In O2 molecule number of bonds is 2. So, bond order is 2. And N2 molecule number of bonds is 3. So, bond order is 3. In CO number of bonds is 3. So, bond order is 3 out here, right. So, this is how we can find out number of bonds between atoms through bond order. And bond order, what is it used for? See, you can see here number of bonds is 3, that means the attraction between atoms is more. So, bond order is used to understand the strength of bond. So, you can write it here, strength of bond is directly proportional, strength of bond directly proportional to bond order. More is bond order, stronger will be bond. So, a triple bond is a stronger bond than double, double is stronger than single. Same way, if you want to calculate bond length, so bond length and bond order, what the relation you can have? I think you will agree that number of bond increases or bond length decreases. So, bond length and bond order have inverse relation, right? And what about bond energy? Bond energy is energy required to break the bond. So, if number of bonds is more, bond will be stronger, if bond order is more. So, bond will be stronger, so bond energy will also be more. So, bond energy and bond order have relation as I am writing it out here. Bond energy and bond order have a relation that is direct. More the bond order, more will be bond strength, more will be bond energy for that particular bond. For example, if we have C single bond C, C double bond C, C triple bond C. So, bond order is 1, 2, 3. Bond energy, bond strength will be more towards triple bond. So, bond energy will be more towards triple bond. Bond length, if I want to calculate bond length, so bond length, as you know, number of bonds increase, bond order increase, but bond length decreases. So, single bond is longer than double, double is longer than triple. So, these are few things which we discussed about bond parameters. I hope you successfully understood everything. Thank you.